Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
After the exhaustion of natural reserves of oil, people will have to rely entirely on alternative forms of obtaining energy. Hydrogen engine, as a replacement for internal combustion engines running on black gold, is one of the prospects of future decades. Power plants of this type have higher efficiency and less toxic exhaust gases. However, the main advantage of hydrogen-powered motors is an unlimited supply of raw materials for fuel production. Water, precisely, it can become the basis of fuel of the future. Interest in the use of hydrogen appeared during the fuel crisis of the 70s, but the first hydrogen engine was invented only in the early 19th century. The technology was actually used during the blockade of Leningrad, when hydrogen was used to fuel the winches of balloons and transportation. Despite the obvious advantages of knowing how to produce hydrogen and use it to run an internal combustion engine, there are several significant buts that slow down the introduction of this progressive technology. Due to the above features, the use of hydrogen as a pure fuel for internal combustion engines is impossible without introducing changes in the design of the power unit, as well as attachments. Design and principle of operation. The main difference of hydrogen engines from the now familiar gasoline or diesel analogues is in the method of supply and ignition of the working mixture. The principle of converting reciprocating movements of the gear train into useful work remains unchanged. Due to the fact that combustion of fuel based on petroleum products is slow, the combustion chamber is filled with fuel-air mixture a little earlier than the moment when the piston rises to its topmost position, VMT. The lightning speed of hydrogen reaction allows to shift the injection time to the moment when the piston starts its return movement to the NMT. At the same time, the pressure in the fuel system does not have to be high, for ATM is sufficient. In ideal conditions, a hydrogen engine can have a closed-type power system. The mixing process takes place without atmospheric air. After the compression stroke, water remains in the combustion chamber in the form of vapor, which passing through the radiator, condenses and turns back into H2O. This type of apparatus is possible if the vehicle is equipped with an electrolyzer, which will separate hydrogen from the resulting water for a second reaction with oxygen. In practice, this type of system is still difficult to implement. For proper operation and reduction of friction force, engines use oil, the vapors of which are part of the exhaust gases. At the present stage of technological development, stable operation and trouble-free starting of a rattlesnake gas engine without the use of atmospheric air is not feasible. Hybrid models and possible modifications due to the great interest in the use of hydrogen as a fuel for internal combustion engines. Hydrogen internal combustion engines have various modifications and types of performance. Schematic diagram of the hybrid hydrogen engine. The motor developed by V.S. Kashchev has a different device. In addition to the inlet valve, 6, for air supply, exhaust valve for exhaust gas outlet, 7, the cylinder head has a separate valve for hydrogen supply, 9, and spark plug, 10, which are located in the pre-chamber, 8. The latter is located in the cylinder head above the level of the piston at the NMT position. After the piston has passed the TDC, hydrogen is fed into the combustion chamber and ignited. The piston draws air through the inlet valves beforehand. At the same time, the exhaust valves open. Due to the difference in atmospheric pressure, the exhaust gases rush into the exhaust manifold, creating a vacuum behind it, which moves the piston to TDC and by impulse back to the lowest position. As you can see, the principle is slightly different, but the essence remains the same. The use of hydrogen as a component of the fuel-air mixture has become even more widespread. To operate an internal combustion engine, conventional fuel and a small portion of rattlesnake gas are used. This allows to increase the compression ratio and reduce the toxicity of exhaust gases. One of the possible ways of development of hydrogen engines is the use of power plants with fuel cells. During the chemical reaction of hydrogen and oxygen, energy is released, which is used to power the electric motors of the car. Difficulties in the operation of hydrogen internal combustion engines. In conclusion, the design of hydrogen engines represents a significant step towards sustainable transportation. By harnessing the power of hydrogen, we can reduce our reliance on fossil fuels and minimize harmful emissions. As we continue to innovate and refine these technologies, the potential for hydrogen engines to revolutionize the automotive industry becomes increasingly clear. With ongoing research and development, we are moving closer to a future where clean, efficient, and environmentally friendly vehicles are the norm. Thank you for joining us on this exploration of hydrogen engine design, and we look forward to seeing how this technology evolves in the years to come.